Hey, this is Gwen Logan. It's Thursday, August 19th at 8:20, and I'm going to try to talk about the Bears experiment today. I did start this process at noon today, and I will try to show you what I've done. Set up the balls, and I set the Bears. So now I think what will happen is I will hold them up. Anyway, I made a paper with the bears. I don't know if you can see them and see them. And I kind of labeled it, but I'll try to explain what it is. But you can see that the bear in the tap water is significantly larger compared to the bear in the normal bear compared to the one that was in salt water. So I'm going to put this down and try to explain it. So the bears went through a process called osmosis. Osmosis is defined as the passage of the selective passage of the solvent molecules. They go through a semi-permeable pore membrane, and that goes from a dilute concentration to a higher concentration until equilibrium is reached. So the bears went through this process. This guy is the normal bear. He is made of sugar, starch, and gelatin, which is a polymer, and the polymer helps keeps that firm structure of the bear. So inside the bear is more sugar than anything, but there's no water in the bear, and the bear acts as a semi-permeable membrane. So this bear is isotonic, and what that means is that it's at a steady state, both sides. It's not it's in a steady equilibrium state in its surroundings, is what I want to say. So that's the normal guy. Now, I'll carefully pick up the bear that was in a tap water solution, and that bear is comparatively larger. Oh, I could show you. That bear is more translucent. It is comparatively larger compared next to the normal bear, and it's softer to touch. So this bear was placed in tap water, and what happened was it created a hypotonic surrounding for that. And so the water molecule, the solvent, went through the bear into the bear and causing it to swell. And it expanded the shape, but the gelatin kept it. It expanded the bear, but the gelatin kept it together. Anyway, hypotonic solution with that tap water bear compared to the isotonic bear, which is the normal bear. And it created a swelling where the volume of that bear increased and until an equilibrium state was achieved. The last bear is the saltwater bear, and we're going to try to hold it up. It is a tiny bit smaller. It is a tiny bit smaller than the other bear, the normal bear, but it's not a lot. And I suspect that the reason it's not as small as it should be, in theory, is because I probably needed to add more salt to the water. By adding that salt, we created a hypertonic solution, and the sugar inside the bear, because it was a lower concentration than the outside, that leached into the salt water. So that in theory is supposed to make the bear shrink more. So because of the hypertonic state. So let me see. I just wrote some notes down because I'm not very good at this video thing yet. However, by adding the salt, we create a hypertonic solution, and inside the bear, the sugar moved from an area of low concentration to the solvent, which is the higher concentration, and that caused the bear to shrink until another equilibrium state was achieved. The last thing I want to say is that this process of osmosis, it's actually diffusion. It's called, the molecules moving around like that is diffusion, and also the osmotic pressure of a solution is what is the pressure required to stop osmosis. So that was from our book and our readings about osmotic pressure, and I think, those things can be measured. We have formulas for that. But overall, this experiment showed me clearly how osmosis can affect molecules shifting between the membranes. And I think that's all I have for tonight, and I hope you enjoyed it. I'll try to get better at this video stuff. Thank you.